The next one we are going to be learning about is dipole-induced dipole forces. So as the name suggests one of the molecules or atoms, rather molecules, basically molecules, is having a permanent dipole, whereas the other molecule or atom is going to have an induced dipole. So obviously a molecule which has a dipole moment can also be called a polar molecule, whereas the one which does not have a dipolar are non-polar molecules or atoms. So what happens here is, first of all we have a molecule AB, okay, and B is more electronegative than A. So this obviously means that that B will have a partial negative charge and A will have a partial positive charge. The dipole moment is towards B, because that's where the electrons are. Now here we have a non-polar molecule, so there's not going to be any distortion in the electron cloud. So what happens is, when this non-polar molecule comes close to the polar molecule with a permanent dipole, what will happen is there will be something called an induced dipole in the non-polar molecule. And the word induced, we've also learnt about them in our London forces or dispersion forces. There also we had learned that because of the instantaneous dipole of one atom or molecule, there will be an induced dipole in the other one. So here the non-polar molecule is going to have an induced dipole, and this is because of the dipole or the permanent dipole of molecule which is polar. So here you have a dipole which is permanent. So I'm just going to, so here you have a permanent dipole. So this particular dipole and induced dipole forces are observed between polar molecules which have a permanent dipole and non-polar molecules which do not have a dipole. So that's why there is an induced dipole forming. So obviously the force is dependent upon two factors. First is the distance. So the less is the distance, more will be the force. So closer they are, more force will it have. Second is the polarizability. And yes, we learnt about this in the first video about the intermolecular, like when we learnt about dispersion or London forces. So polarizability and distance. Polarizability is for the non-polar molecule. So if this non-polar molecule, if it's easy for us to split the positive and the negative, that is the nucleus, if it's easy for us to distort the electron cloud, then the polarizability is high. Then obviously it will be easier for it to form the dipole or for it to have an induced dipole, and more will be the force of interaction between these two molecules. And distance obviously similar to the other ones, closer they are, more more is the strength, or more is the strength of the interaction between the dipole and the induced dipole. One more important thing we need to remember over here is that when the strength, so the polarizability depends upon the size of the atom or molecule. So when there is an increase in the size of the atom or molecule, the effect of the electric dipole on it increases, and so it can easily separate. Now there is also one more thing. Here in this case, in case of dipole-induced dipole forces, we'll assume that a molecule or the mixture consists of both polar and non-polar molecules. So there is going to be dipole-dipole forces between the polar molecules, and there'll be dispersion or London forces between the non-polar molecules. So all of those forces will also come into play in dipole and induced dipole forces. And obviously the interaction energy is inversely proportional to r to the power 6, where r is the distance. So dipole and induced dipole forces is between polar and non-polar molecules. So polar molecule is going to have a permanent dipole, non-polar molecule does not have a dipole, and there is no distortion of the electron cloud. So when a polar molecule comes close the dipole moment of the polar molecule is going to induce a dipole in the non-polar molecule, and this is so the strength of this is dependent upon the distance. Closer they are, stronger it will be, and polarizability of the non-polar molecule. So more polarizable the non-polar molecule is, more will it, easier will it be for us to split the negative, for us to get the partial positive and the negative charge. More will be the attraction. The interaction energy is obviously inversely proportional to the distance taken to the power 6. With that, we're done with the 3 forces. Well, first was dispersion of London forces, second was dipole-dipole forces, the third was dipole and induced dipole forces. These 3 forces cumulatively are called as van der Waals forces. Van der Waals forces is one of the weakest interactions that we observe between atoms or molecules, and these 3 forces are responsible for the van der Waals forces. In the next video, we will be discussing about hydrogen bonding.